All right. So, excuse the voice. I've been a bit sick. Um, Sorry to not be in class, but technology, we love it. All right. So, here's some problems that we worked on: finding the third side of a triangle using the Pythagorean theorem, simplifying some radicals. We talked about special right triangles, and we found some side lengths using the properties of special right triangles. I'd like you to turn here to part two, solving right triangles, and I'm just going to explain a few things to you. Um, and then as you're working through, you can use this video, or if you can figure it out on your own, that's also okay. So first of all, to solve a right triangle, if someone tells you to solve a right triangle, what they're asking you to do is find the lengths of all sides and the measures of all angles. So when it says solve a right triangle, that's really what you're being asked to do. So definitions, there's a couple things we need to know in order to solve some practical problems that involve triangles, and that is an angle of elevation and an angle of depression. You can see this diagram to help you understand what an angle of elevation and depression is. Hmm. So an angle of elevation is an angle formed by a horizontal line and a line of sight to a point above. Make sure you know that it's from a horizontal line. So if I have a horizontal line like this, I would have to be going up from the horizontal to have an angle of elevation. This right here would be an angle of elevation. An angle of depression is kind of the opposite. That's an angle formed by a horizontal line and a line of sight to a point below. So maybe you're standing on top of a cliff looking down at something. That is the angle of depression there. It's very important to know that these angles can never be measured from the vertical, never measured from the vertical. Okay, so for instance, if I have a vertical line and I have an angle that's made there, that cannot be an angle of elevation or depression because it's not measured from the horizontal. Again, if I have a vertical line and I have an angle measured from the vertical line, that cannot be an angle of elevation or depression. This is a very, very easy thing to confuse, which is why I'm taking a little bit of time to explain it. So whenever you're drawing an angle of elevation or depression, make sure you have a horizontal line first. Elevation, you're going to measure up from that line. Depression, you're going to measure down from that line. Okay. So coming down here, classify each angle by describing it as an angle of elevation or an angle of depression. I would encourage you to look at this picture, maybe pause the video and try on your own first. Decide, am I measuring from the horizontal down, or am I measuring from the horizontal up, or am I not measuring from the horizontal? In which case, it would not be an angle of elevation or depression. So hopefully you've already tried these. If not, again, I would pause and write down your thoughts before you watch the video. But angle one, that's an angle of depression. We are measuring from the horizontal downwards. So that's an angle of depression. Angle two, however, is measured from the horizontal up. That's an angle of elevation. Angle three, again, measured from the horizontal down. So that's an angle of depression. And angle four from the horizontal up. That's an angle of elevation. Now, there are some things that you may notice are congruent here based on what we know about parallel lines. These horizontal lines are parallel, right? So angle one and angle two, those are alternate interior angles. So in this case, these angles are congruent. and that can be useful when you're drawing pictures. The angle of depression and the angle of elevation are going to be congruent in that case. And coming down here, these are also alternate interior angles, right? Because they are on either side of the transversal right here that's cutting these two parallel lines. So these are also congruent angles. So that can be useful when you're drawing pictures. Okay, so let's try this problem. First thing you always want to do is draw a diagram and then figure things out as you go along. An eagle on top of a 65-foot cliff spots a fish in the water and dives toward it. The angle between the cliff and the eagle's path is 36 degrees. You'll notice this does not say angle of elevation or angle of depression. That's because it's the angle between the cliff, and the cliff is probably vertical. We're going to assume that it's vertical. So here's our 65-foot cliff. There's an eagle up here at the top. I've literally seen eagles diving towards the water recently, although they were going for coots, which are birds. Spots a fish in the water. So the fish is down here in the water. And it dives towards it. We're going to assume that it goes in a straight line. Okay, so here's your fish. Here's your eagle. And we know that the angle between the cliff and the eagle's path is 36 degrees. That's 36 degrees right there. Okay, we're going to assume this is a vertical cliff. Okay, so we've drawn a picture. It looks pretty good. Of course, if I want to, I can find this angle as well. I don't necessarily need it, but I'll write it down in any case, right? If all three of these add up to 180, 180 minus 90 is 90. These two angles right here, right? These two angles should be complementary, right? They should add to 90 degrees. So that means that this is the 54-degree angle. It's not necessarily needed, but I might as well just put it down because I do know that that's true. Okay, so assuming the eagle flies in a straight line, how far will it fly to reach the fish around to the nearest foot? So I am looking for this distance right here. Excuse me. When I'm looking for a side, I want to use my trigonometric functions. So I could use either angle. Because this was the angle that was given to me, I'm going to focus on that angle. So x is, of course, the hypotenuse of the triangle because it's across from the right angle. And 65 in relation to 36 degrees is the adjacent side. It's adjacent to 36. If I used 54, then it would be opposite. But I'm going to use the 36-degree angle, and since 65 makes part of that angle, that's the adjacent side. So remembering my little mnemonic, so katoa, I'm looking for the trig ratio that relates hypotenuse and adjacent. Well, that's cosine. So now I can write my equation. Cosine of 36 degrees is equal to the adjacent side divided by the hypotenuse, 65 over x. Now, if I want to get the variable out of the denominator, I can multiply by x. That will give me x times cosine of 36 degrees equals 65, because these x's are going to divide to get 1. And so x is going to be cosine of 36 degrees divided by 65. I'm going to let you get a decimal approximation to that and round it to the nearest foot. Okay, this next question is kind of stepping outside of trigonometry a little bit. It said bald eagles can dive at speeds up to 100 miles per hour or about 145 feet per second. That's quite fast. If the eagle's average speed is 120 feet per second, how long will it take to snatch the fish? Well, I just want to remind you that distance is equal to rate times time. And that makes sense because if I drive at 60 miles per hour for, say, 3 hours, it makes sense that if I'm going 60 miles each hour, and I'm doing that 3 times, I'm going to go 180 miles total. Well, they're giving me the rate right here, which was 120 feet per second. And up here, you found the distance. So how long will it take to snatch the fish is asking you to find the time. Since distance equals rate times time, I know that time is going to be distance divided by the rate. So you can use this little equation, your answer for the distance that the eagle flew, along with the average rate that was given, to find that time. So I'll let you figure that out. Okay, let's look at number 4. I'd encourage you to try and draw some things ahead of time if you can, and then use the video if you need some support. A boat on the surface of the water detects a whale 42 feet away at an angle of depression of 20 degrees. Okay, so here's my boat. Not the greatest boat, but it'll have to do for now. Here's the surface of the water. That's my horizontal, of course. So remember that an angle of depression is measured from the horizontal down. 20 degrees is not very much. So I'm going to draw a fairly narrow angle here. That's my 20 degrees. It's measured from the horizontal downwards. Do not measure it from the vertical. This is not 20 degrees here. So that is not the angle of depression because the angle of depression should be measured downwards from the horizontal. That's the definition. Okay, we've got a whale here. Now it's 42 feet away. 42 feet, we're always going to assume that if it's 42 feet away, that's the straight line distance, not the horizontal distance, not this, not the horizontal distance, but the straight line distance. If we look straight at the whale, that's 42 feet. So that is our diagram. If you put 42 feet up here, that is a very reasonable mistake to make. But that would be the horizontal distance. And we want the straight line distance. The shortest way to get to the whale is along the hypotenuse, and that is the 42 feet. To the nearest foot, what is the horizontal distance? Ah, there they're asking for it. And then it says round. I'm not sure why it doesn't say round to the nearest tenth or something. To the nearest foot, what is the depth of the whale? So let's call this x, our horizontal distance, and let's call this y, our depth. Okay, since we were given the angle 20 degrees, let's use that angle. However, I do know that this angle is 70 degrees. So I could use that angle if I wanted to, but I'm going to focus on the 20 degrees because it was the angle that was given. Okay, so this is the hypotenuse. This is the adjacent side to the 20-degree angle, and this is the opposite side to the 20-degree angle. Remember that if I used the 70-degree angle, these would swap, but I'm just going to use the 20-degree angle. In order to find the horizontal distance, that's the adjacent side, and I have the hypotenuse. So what I can do is use cosine. Cosine of 20 degrees is equal to the adjacent divided by the hypotenuse. So that means that x is just going to be 42 times the cosine of 20 degrees. And I'll let you find that actual distance. Now, to find the depth, that's now the opposite side, and I have the hypotenuse. So opposite and hypotenuse is sine. Sine of 20 degrees is equal to y divided by 42. So that means that y is going to be 42 times the sine of 20 degrees. And you'll probably start to recognize some patterns here. Like if you want this, sort of horizontal adjacent side, you're going to be using cosine. Whereas if you use this, want this vertical opposite side, in this case, you're going to be using sine. So you may recognize some patterns, but I would just encourage you to show your steps to make sure you're not making any mistakes. Now I'm going to erase this adjacent and hypotenuse and opposite because they do change, right? The adjacent and the opposite depending on which angle you use. So again, you would need to find a decimal approximation for this using your calculator. Okay, let us look at number 5. A person standing 30 feet from a flagpole can see the top of the pole at a 35-degree angle of elevation. The person's eye level is 5 feet from the ground. Okay, first of all, let's draw the ground. So here's the ground. There's a person standing here. Okay, we'll just do a little basic person. And their eyes are 5 feet above the ground. So this is 5 feet. They can see the top of a flagpole. So we've got a flagpole here. Let's draw a little flag. Maybe it's, celebrating love and happiness. So we've got that nice little flag. Excuse me. We know that they're standing 30 feet from the flagpole. Now, it really should say 30 feet from the base of a flagpole. So if you said that this was 30, that might be an okay way to interpret the problem. But I don't really think that is what it's meant to be. I think it's supposed to be the person is 30 feet from the base of the flagpole. Now, they can see the top of the pole at a 35-degree angle of elevation. So they can see. We're going from their eyes. So let's draw the horizontal from their eyes and measure up 35 degrees. That is now our diagram. Now you notice that we have a triangle, but the triangle is also 5 feet right above the ground. But we still know that this base here is 30 feet. So if we wanted to simplify, we would just have this triangle right here where the angle of elevation is 35 feet and this is 30 feet. But remember that whatever height we get here, let's call this y, we're going to have to add 5 to it because this whole thing is 5 feet off the ground because we're going from eye level. So if we want to find that height, let's find y first and then we can add 5. This is the opposite side to the 35 degrees, and this is the adjacent side to the 35 degrees. This is the hypotenuse, which we don't really care about. So what we can do now, I apologize for the sniffling, is we can say, well, what trig function uses adjacent and opposite? That's tangent. So tangent of 35 degrees is equal to opposite over adjacent, which means that y is going to be 30 times the tangent of 35 degrees. The height, of course, is going to be that value plus 5, right? And hopefully you can see from the diagram whether that would be. You're going to have to use your calculator to get a decimal approximation of that. Okay, I think you can solve these triangles, so I would invite you to do that. Remember that finding this angle is going to be very straightforward. You can give this a little variable if you want. Once you find x, you could use the Pythagorean theorem, or you can use a trig function again. I might go ahead and do this, but I'd very much encourage you to pause the video and try these on your own. But I'll go ahead and do it now. So if this is 51 degrees and this is 90, I know that these two angles are complementary, these two right here. No, my pencil stopped working. And so what that tells me is that this angle is 39 degrees, 39, 40, 90, yes, 39 degrees. Okay, if I want to find side x, this is the opposite side to angle 51, and this is the hypotenuse. So I could use sine. I could say sine of 51 degrees is equal to 14 divided by x. And then I could solve that equation for x. I think I would end up with x equals 14 divided by sine of 51 degrees. And I would let you get a decimal approximation for that. To find y, I would be tempted to use 51 degrees again, but now we have the adjacent side. So I could do cosine of 51 degrees is equal to y Well, I guess cosine maybe doesn't make the most sense because then I have to use x. Maybe instead of using cosine, I mean, I know I found x up above. I could use tangent because it's opposite and adjacent, and I know that the opposite is 14. So what about saying tangent of 51 degrees is equal to 14 over y? And that would tell me that y is going to end up being 14 divided by tangent of 51 degrees. Once I have a decimal approximation for y and for x, and I've found the other angle, I solved the triangle. Now, in this second example, I'm given two sides, and I don't know either of the acute angles. So I'm going to need to use an inverse trig function to find that angle. Remember that this symbol here is a Greek letter named theta. So that is a variable that we often use, like x and y, but we often use it for angles. So that's just theta. So if I want to find theta, this is the hypotenuse, and this is the adjacent side to theta. So I know that cosine is adjacent over hypotenuse. So if I already have the adjacent over hypotenuse ratio, I can use the inverse cosine to find my angle. And that's going to give me my theta value. And you can find that on your calculator. Once you have that, it won't be hard to find the measure of angle B because you can just use the triangle sum theorem, right? Angle B, or sorry, uh, we know that all three angles add up to 180. And finally, this third side, I would recommend using the Pythagorean theorem. Or perhaps you remember that this is a Pythagorean triple, 5, 12, 13. So I know that this side is going to be 5 just based on my knowledge of special right triangles. If you don't have that memorized, you could also do x squared plus 12 squared equals 13 squared. And trust me, you will get x equals 5. All right. Thanks for watching.